Hi, everybody. I'd like to welcome you back to the main room of this conference, and very happy that we have so many attendees. It's Saturday afternoon here, but so many people want to hear more. And I'll introduce the next speaker, Samuel Mehr. He's a research associate in the Department of Psychology at Harvard University. He directs the music lab. The lab's research asks how and why the design of the human mind leads us to perceive, create, and engage with music across human societies and across the lifespan. Originally a musician, Sam earned a music degree in music education from the Eastman School of Music, followed by doctorate in human development at Harvard under the mentorship of some very famous people. Now he's the director of the Harvard Music Lab. And I would like to say he's a very young scholar, but if you look at how his work is progressing, you could just tell that there'll be so much work coming from there. So that's why we're excited to have him. He's young, but you can just tell that there'll be many papers and many interesting papers coming along very soon. And I wanted to mention one of them. It was the Universality and Diversity in Human Sound that we read last year at Journal Club. So we have here a Music Cognition Journal Club at McMaster across several labs. And I personally, the first thing that grabbed my attention from that paper was the cross-cultural component. That's also important the whole day today. I myself have this weird musical background. I grew up listening and dancing to some of this Balkan folk music that just sounds so different from anything you get here in the West. That's why I get excited when I see people trying to give a systematic account of these different musical traditions. What's different and what is common among them. So we got his paper and we spent a lot of time on it. It was one of the kind of more heated and engaged journal clubs from that year. It was very serious, a lot of very difficult computational methods made part of this paper. So in addition to being very kind of prolific in that respect, I'll let Sam take over from now. I just wanted to point out he's brave enough to give his talk live. So you can really interact with him right now. And before I let him start, I'll give him the stage. There's one last thing I wanted to point out. To ask your questions, please click the Q&A button at the bottom of your Zoom screen. You can also, of course, use the chat, but we're more likely to raise your question if we see it in the Q&A box. And with that, I'll let Sam take over.
Cool. Thanks for introducing me, and thanks to Laurel and everyone who's organizing the meeting today. One other thing I'll say, because we're live today, is anybody who wants to turn on their video and be kind of live together, please, if you're in the panelist window already, you can just turn it on and we'll see you. If you're an attendee and you'd like to be part of that virtual group, just raise your hand now. And Cassian, our super on top of things tech support person who's awesome, is going to add you so that you can be live as well. So anyone who's comfortable being live, go ahead, raise your hand and you'll be added now. And others can see you as well. And we'll have a little group session live. Let me just get my.
So people are being added right now. Just a reminder that to keep your hand raised, and I'll promote you up to a panelist, and at which point you can share your video as well.
Awesome. I'm already seeing people added. So one reason that I'm doing this live, which I'll use as a caveat to the beginning of my talk, is that I'm on parental leave at the moment. So I didn't actually have time to put together a recording. But we'll count that as a positive in the positive column, so that we can have a little bit of together time during this meeting. Yeah, awesome. I'm seeing lots and lots of people. This is great. So as you get set up, I'll just by way of introducing the talk, I wanted to start with an example that I've been using in a couple of recent talks to kind of point us in a bigger picture question, which is basically, why should we even care about music in cross-cultural perspective? So this might be a little bit, well, of course we care about music in cross-cultural perspective. There's a lot of different ways you could answer this question. But for kind of a quirky answer to this question, I wanted to start with a fun example from the machine learning world, which was going around Twitter a couple of years ago. And this is an example of a machine learning application that asks whether we can teach machines to listen. And it used as a kind of test case a very straightforward task that all of us can do pretty well as experienced listeners, which is just when presented with a tone played by an instrument, can we make a reliable inference about what instrument is playing that tone? So this is it was a Medium post by John Hartquist, who some people in the music information retrieval world might know. And he had this very cool approach to taking a tone like this one. I'll play you it. Hopefully people can hear that. And it just asks what instrument is playing that tone. You might have some intuitions yourself. It might sound like a woodwind, maybe a saxophone. And John's approach to this question was very straightforward. He generates a spectrogram on the fly and applies image recognition techniques. So there's this enormous world of machine learning techniques for classifying images. And rather than doing anything in particular with the raw audio, he just takes the image of the spectrogram, runs it through a deep learning algorithm on a large data set of musical instruments, and tries to predict what instrument is playing. This turns out to be really, really effective for classifying isolated tones like the one you just heard. So here's how the model does. This is a confusion matrix. Along the x-axis is what the model predicts, and along the y-axis is what was actually being played. And what you can tell from the heat map, you can blur your eyes, you don't need to see the numbers themselves, but the model is very, very good. When the model hears what's actually a string instrument, more than 99% of the time, it predicts this is a string instrument. So this is an example of really, really good machine listening, we can say. This is a model that is very, very good at being able to tell what instrument is playing a tone. Now, why am I starting with this example? What does this have to do with cross-cultural psychology of music? The answer to this question is yes, we can teach machines to listen in at least this case. But there's a bit of a caveat, which is that this is a very, very isolated, very simplistic example of machine listening. In fact, all of the information that you need to make the classification decision is present in that spectrogram that you just saw. So the but of this yes, but is what about harder things in machine listening? What about higher level representations, more complicated problems of the sort that children and even young infants can do, which we know largely through the work of many of the people who are on this call. These are higher level problems in music perception and in acoustic, in auditory perception, things like auditory scene analysis, tonal, metrical representation, aesthetics, really high level stuff, where a lot of the information that we're really interested in, that we experience day to day as ordinary humans, where that information is not necessarily explicitly present in the information that's in a spectrogram like the one you just saw. So as a psychologist, when I see that model, I think a little bit, where is the psychology? Now, it is the case that in auditory cortex, one of the basic things that we're doing is a Fourier transform and turning vibrations of air into bits and doing classification of tones. But of course, for some of these very high-level representations that we think of when we kind of canonically think of music perception, that's not going to be enough. So what is that psychology? And this gets me back to my first question. Why should we care about music across cultures? Well, the minds that are doing music perception are happening in every single culture. They're not happening only in the cultures that we happen to have easy access to in whatever city you happen to be sitting in, if you're sitting in a city at all. And I think that a sort of well-reasoned answer to the can we teach machines listen to question is maybe those machines need something like a psychology of music. But in order to build that psychology of music, we need to know what we should be building. We need to know what the basic building blocks of that psychology are. We need to know what a human psychology of music is. And a human psychology of music, by definition, needs to know what's going on in the minds of listeners across cultures and not just in some cultures. So this is a motivating question that's been going on in my work since I was a graduate student and now in my lab. And in today's talk, I'm going to present a few different case studies of places where we've found that we have sort of a surprising level of regularity in the psychology of music across cultures. Now, a key roadblock to answering that sort of big picture question of what is that human psychology of music is one that everybody else today has already mentioned, both in discussions and in the talks that we've seen so far. And that key roadblock is the fact that we don't actually have as much information as we would like about music perception and music production across cultures. A big reason for that is the weird people problem that others have mentioned. The fact is, through quirks of the sociology of science, through the people who happen to be studying music, we have very little information about what's going on in the minds of listeners around the world, with a few exceptions, including Nori's work from earlier today and the work of a few other papers that I've mentioned on this slide. And one reason that we have this big weird people problem is not for lack of data, but for lack of the tools and the effort to assemble data from different places. So there are, in fact, large bodies of work that study music across cultures. There's an entire field of ethnomusicology. There's the field of anthropology, which has often studied music in great detail. But an issue in these fields is that the access to data that's collected from these different projects and from many, many different cultures is fairly difficult to systematize across cultures. So there's lots and lots of information out there in books, in libraries, in archives, documenting systematic information about how music is used and how people hear music around the world. But there aren't very many repositories of those data that let you do systematic cross-cultural analyses in a way that would let you make big picture inferences about what might make up the human psychology of music. So this is a problem that we've been trying to address through a collection of projects that together we refer to as a natural history of song, which I used sort of colloquially as the title of my talk. This is an interdisciplinary effort with people from a bunch of different fields aiming to solve that problem, to solve the weird people problem and to solve the sort of data access archival issue problem, where we want to assemble systematic data sets of music production information so that we can then use that information just in analysis, but then also in experiments with human listeners to try and figure out what are the building blocks of the psychology of music. And today in the talk, I'm going to present a few adventures in cross-cultural data science using these tools. And I'm going to focus on a case study, which is sort of a theme for a lot of our projects that has to do with what listeners understand or not about music that they've never heard before. So first I'm going to talk about some work that people may be familiar with. This is already a couple of years old, but just asking what do listeners think they're listening to when they hear music that they've never heard, when they hear music from cultures that they're unfamiliar with. Is it entirely unfamiliar to them, or do they bring with them a bit of understanding of this music despite their unfamiliarity? We're going to ask what particular musical features from these songs around the world are universal and what features aren't. Because these sorts of universal features, or at least universal proclivities to use one feature or another in a given context, could underlie people's understanding of music around the world. We'll ask the degree to which listener experience affects these sorts of inferences, in particular by studying children who have quite rapidly accruing musical information in their musical experience as they grow up. And then towards the end, I'll just mention some new work that's just come out a couple of weeks ago from my lab, looking at physiological effects of music listening on very young listeners to try and get at our least experienced listeners, human infants. Okay, so let's dive right in with that first question. We're going to ask, what do listeners understand about the music that they hear? So to ask this question, we used a corpus that I built with a couple of co-leaders, Manvir Singh and Luke Loake, as a graduate student. We call this the Natural History of Song Discography, the NHS Discography. This is a very small corpus, it's only 118 songs, but it represents a rather diverse group of cultures. The songs come from 86 different societies. And they come from 4 particular musical contexts that we were interested in. These are not exhaustive. Of course, there's many kinds of music that don't fall into these categories. But as a starting point, we were focusing on dance music, music that's used to heal illness, as in shamanistic healing ceremonies, love songs, songs that are used to express love to another person, and lullabies, songs that are used between parents or alloparents and infants to soothe or put an infant to sleep. So we have this corpus of music that we built. If people are interested in how we built it, we can maybe talk about it a bit in the Q&A. And the first thing we wanted to do with it was just ask, when we play these songs to naive listeners, what do naive listeners understand about what they're hearing? We ran a very simple experiment. What happens is each listener hears a little snippet of a song that's drawn at random from someplace in the singing portion of the audio. So we don't get just an instrumental portion, but there's always a voice in the recording. We ask the listener how much they think the song is being used for a particular purpose. Those purposes correspond to the actual purposes that each of the songs in the corpus are used for, things like used to soothe a baby, used for dancing, used to heal illness, or used to express love to another person. We also have some control measures, which I'll leave for now. And we do this a bunch of times, so each listener hears many, many different songs. And it looks very simple. It's a 6-point rating scale, and we ask for each song all of these different categories. And just for fun, I figured we would do this with the group here. Since we've got a nicely sized sample, we ought to be able to replicate the results before you've even heard what they are. So Cassian has prepared a poll for us, and I'm going to be playing you 3 different examples. And through the Zoom polling feature, you'll be able to respond with your intuitions about one of these questions. We'll focus specifically on whether you think the songs are being used to soothe the baby. So Cassian, if you could go ahead and launch that poll. So you should see a poll appearing on your screen. I'm going to play you a song, and I'll ask you to think of the singers and then choose one of these 6 options, whether you think the song is not used to soothe the baby or used to soothe the baby or somewhere in between. Here we go. So go ahead and submit your answer. There's no right answer here, of course. You can say whatever you like. And once everybody's answers are submitted, I believe we should be able to see the results here.
You'll give them about another 15 seconds, and then I'll share the results here. A few more people are still voting.
No worries. And as we're waiting for the results to come in, what we're going to look at here is both the mean of the distribution that comes in, so what the kind of collective view of everyone's sort of inferences are, but also the degree of agreement between one another about how spiky is this distribution, or is there a lot of disagreement among those of us on the call answering the poll right now. Okay, so here's what we find. Can everyone see that? Yeah. Okay. Cool. So. Collectively, our view is that this is sort of towards the not used to soothe a baby end of the scale. There's a little bit of disagreement. Not everybody has answered 1 or 2 here, but there's a clear peak to the distribution. Okay, let's do it again with another song. Here comes one more. I'm going to ask you the same question. Okay, go ahead and submit your response. And I'm sorry to those who have seen me give this talk or give these slides before. You're probably familiar with these songs because I've been using these clips for a while. Okay, let's go ahead and see what the results look like. Okay, so we've got a bit of a different distribution here, although more ambiguity in people's responses. There's quite a bit more variability in that distribution than the previous one. This one's going more towards the soothing a baby scale. Okay, and we'll do one more example just for fun. Here it comes. Okay, go ahead and submit your response. And of course, the point of doing this exercise with everyone is just to give you a sense both of what our participants did, but also the degree of variability that we see with the responses. As I said before I played any examples, there isn't actually a right answer to any of this. There's an answer of what the culture themselves are using for this song. But of course, any song could be used for any purpose that you feel like. It's more about your own intuitions for how these songs are being used. So here's the result of that one. And as you can see, there's, again, here a nice strong peak towards the end. That last one was, in fact, used to soothe the lullaby in the culture that it came from. And while there is still a degree of variability in the distribution of responses, it's the peakiest one yet. It's a very clear agreement from our listeners here in the room that this is a song that's indeed used to soothe the baby. Okay, so you get the idea. This is sort of the general how our experiment works. What did we find across a larger group of participants? In this first paper, we ran the study with 750 people, reasonably large sample size. These are M-Turk workers on Amazon Mechanical Turk, people who share some musical experience because they're people on the internet, but people who have some geographic diversity. They come from 60 different countries. The 60 countries are not evenly distributed around the world, though. M-Turkers are heavily clustered in the US and in India, and then in a number of other countries in much smaller numbers. And each participant listens to 36 excerpts, so this works out to many, many listens for each song, giving us quite a precise estimate for the kind of global consensus for how lullaby-like or how healing-like or dance-like each song is. So here's what we find. On this plot, each point is going to be a song and its average rating on this measure used to soothe the baby. I'm going to group the songs by what they're actually used for in the cultures where they were recorded, or at least what they were used for according to the anthropologist or the ethnomusicologist who collected the recording. And along the y-axis is the rating from 1 to 6. One thing to point out here is the rating on the right y-axis, which is just a normalization of that to give you a sense of the effect sizes. At risk of spoiling it, the effects are quite large, and that's why we put that scale there, just to give you a sense of how large they are. So, when people are listening to songs that are actually lullabies, the green songs here, they rate them as likely to be used to soothe the baby much, much higher than the other three song categories, and also much higher than the global average for this rating, which is delineated by the dotted line. Another cool result here is that dance songs and healing songs are really rated quite low on this dimension, so much so that you might think dance songs and healing songs are really not for soothing babies. They really don't fit that category, at least to our 750 listeners. When we ask other questions, like how much each song is thought to be used for dancing, we get a very different pattern of results. So here, dance songs are picked out much, much more than the other song categories, and lullabies are very much not used for dancing, so much so that the highest rated lullaby is below the global average on this measure. Lullabies are really, really not for dancing, according to our listeners. In a more surprising result to me, so dance songs and lullabies are fairly stereotyped, and they're really, really different than one another just by anyone's sort of common sense. A more surprising result to me was about healing songs. You might think that M-Turk workers who probably have not too much experience with shamanistic healing, at least in 2018 or 2017 when these data were collected, they're still able to pick out the healing songs, although with a somewhat smaller effect size. So this is an effect size more like what you would find in a typical social psychology study. The z-score is about 0.5. The previous effects here, the difference between lullabies and dance songs, are roughly the size of the average difference in height between males and females globally. It's an enormous effect. This is a much smaller effect, but still a reliable one, where our listeners are able, on average, to pick out healing songs from the other three song types, but they're much less sure of that distinction. The only category where we didn't see an effect like this was love songs. Love songs appear to be much more ambiguous, or at least ambiguous to our M-Turkers, such that they weren't able to reliably distinguish them from the other song types. Now, you might be wondering how consistent listeners were with one another. When we tried the experiment just now on our Zoom poll, you could see that there was quite a bit of variability between listeners on our intuitions for those three songs we listened to. So to measure that, we compared subgroups of our listeners to one another. We compared our Americans to our Indians to everybody else. So this is a very coarse comparison, but it's a first step. And in each cohort, we still have 250 people, so they're still hearing quite a few songs. And because of that, the precision of each estimate is still pretty good. So to do this analysis, we simply are going to ask, how much do the cohorts agree with one another? So on this dimension used to soothe the baby, we're going to plot each song in three-dimensional space where each dimension corresponds to one of the cohorts. So if the cohorts agree with each other quite reliably, we should see a line right down the diagonal of the cube where everyone agrees on how lullaby-like each song is, regardless of how lullaby-like it really is. If they disagree with one another, we should see a cloud of points or some other pattern. Here's what we find for the lullabies. The green songs are the lullabies, the gray songs are everybody else. And what you can see is that it's quite close to a diagonal line, a nice high R squared value. And within each cohort, there's a clear distinction between these lullabies and these non-lullabies. We see similar patterns on the dimension used for dancing. Here, the blue songs are the dance songs and the gray songs are the other three. And even with healing songs, where we know that on average the ratings are more inaccurate, there's still quite a bit of agreement among listeners for what constitutes a healing song, even if their intuitions are wrong. You can see there's also a bit of skew in this one, where people in the world cohort, the non-Indian and non-US listeners, are more likely to rate a song as used for healing than the other cohorts are. So we were interested in replicating this, in part because M-Turkers are sort of a strange population for a number of reasons, and also because this is a fairly small number of people from each of the different countries that we were studying. Another motivation for this replication came from the methods end, which some of you here may be interested in speaking about later on, especially given how many people are running studies online. And that motivation came from a press article that was written about this first paper that came out. The New York Times did a little piece about the history of studying music across cultures and this sort of new foray into the field for our lab. And one of the things that the Times team did when they published this article was they made a little applet that let its readers listen to some songs and make some guesses themselves. And in the space of about 7 days, I think they had something like 200,000 or 300,000 people do this game. So we figured if the New York Times can do it, we ought to be able to do it. And we built themusiclab.org, which is our citizen science platform for running experiments on the internet. If you've seen a talk of mine recently, you're probably bored and have seen these slides, so go ahead and go onto our site and play some games to pass the time if you like. If you've got a kid and you haven't played our kids game online, give that one a try because we're recruiting for that one quite a bit. And one of our first games on this site was called the World Music Quiz. And it was exactly like the New York Times game. We played people songs and asked them to make a categorical classification. Is this song a lullaby or not? Given the choice of these 4 song types, which one would you classify it as? And importantly, that's a slightly different measure than we used in that first set of results that I presented, where each song was rated on a number of different dimensions. Here, we're forcing people to make a choice. Maybe it can be used for more than one, but for now, just make one choice. So in our first report of these data, we studied about 30,000 participants coming from 110 different countries, much broader sample of people. The study's done in English in every country, but the site itself can be translated by Google Translate. And in fact, a large number of our users run the site in a Google Translate window so that they can do it in their native language. And in this plot, I'm going to just show you the confusion matrix of the classifications. One thing I want to draw everyone's attention to before I do that is the base rates of responding in each of the category types. So in the green box along the bottom of this plot, you can see that people use the different category types unevenly. So people are more likely to respond, regardless of what they're listening to, that a song is a healing song than anything else. Maybe because healing is the most ambiguous category to them, who knows? But what that means is when we look at the data, you're going to want to compare not to chance level of 25%, but to the base rates of performance here. And corresponding to that, we'll be showing D prime scores, which take that sort of base rate distinction into account. So what do we find? When people are listening to songs that are actually used for dancing in the culture that they come from, they're by far the most likely to respond as used for dancing, nice high D prime score. Same deal for lullabies, even higher D prime. They still get healing songs, just like in our first paper, but with a smaller effect size, as you might expect. And in one difference between these results and the first paper, they're also reliably able to identify love songs, but it is the smallest effect of the 4 song types. So this gives us some confidence in our first set of findings that adults make reliable, high-level inferences about the music that they hear. And to tie this back into the first example that I started with, none of this information is reliably present in what you would get if you looked at spectrograms from that song. There's some hints to it in those spectrograms, but it's not explicitly present. These are inferences that are brought to the table by the minds of the listeners that are there. These are structures that are being imposed on percepts that a sort of domain general, untrained machine learning model would be at pains to do. So we wanted to dig into this a bit more and ask how this is actually possible. Like what features are making this work? So what are the song features that make this that make these sorts of inferences happen? There's a lot of results in the paper about this, and I'm going to focus on just one set of them, focusing on lullabies for now, since I mentioned those a couple of times. We analyzed these songs with a few different types of quantitative and symbolic representations of musical content, and that's because this is music from lots of different cultures, and there isn't any widespread agreement in the field about how you might represent this sort of music quantitatively. So our approach was to throw the kitchen sink at it, to measure it as many ways as we could, and to see if we got convergent evidence for some set of features across these different representation types. We used music information retrieval, tools that are pretty well known to this group, I think, from Mehr Toolbox and the Pantelli paper on cross-cultural music information retrieval. We used naive annotations. So these are annotations from people on MTurk, untrained listeners, rating very simple features, things like how fast is this, fast or slow? How complicated is it, complicated or not complicated, those sorts of ratings. We had a group of expert listeners. These are people with masters or PhDs in music, ethnomusicology, music theory, who are able to label things with high reliability, things like key areas and how consistent a macrometer is present, and naming pitch classes that they think are important to the song, those sorts of things. And then we had a data set that was even higher level than that, where we actually transcribed these songs in staff notation and extracted the sorts of information from those transcriptions that even expert listeners are at pains to provide. Things like, what's the pitch density of this song? What's the set of intervals that are used in the song, and which one is the most common interval? Those sorts of things. And then to ask about what features most universally characterize these different song types, we use a fairly common tool in machine learning that's not that common in psychology. So I'll tell you a little bit about what that is. It's called a logistic lasso. And the way this model works is it uses cross-validation in kind of a clever way to figure out which features are predictive of the differences between song types in every world region that we've studied. So what we do is we train the model on pairings of songs from 29 of our 30 world regions. And these are pairings like lullaby versus dance, lullaby versus healing, lullaby versus love. And of course, there's 6 pairings because we have 4 song types. And then in the 30th region, we ask the model which in each pair, which song is which. We then rotate the model across all of these different regions. And what's cool about this lasso method is that across the different regions, it starts to knock out features that don't work consistently around the world, leaving you with a set of features that most reliably characterize these song pairings across cultures. So it's a strong test of universality in that we explicitly divide up the world into many different regions and force our model to work in all of those regions. Does that make sense? Okay, so what do we find? For the lullaby comparison, which I'll focus on here, first, the model works. So the model is able to accurately distinguish between lullabies and non-lullabies in those held out regions, quite accurately, in fact, more accurately than human listeners do. And we can just make a little map. We can say what features characterize these differences. And the features are ones that you might already expect. These aren't going to be very surprising to anybody who's ever sung a lullaby or has had a lullaby sung to them. So lullabies relative to dance songs have slower tempos, they have fewer rhythmic accents, and less consistent meter. Big surprise. Relative to healing songs, this might be a little bit more surprising. Lullabies seem to have fewer rhythmic accents. Okay. They seem to have more minor key qualities. That was surprising to me, at least. And they have fewer unique pitches. So lullabies are characterized by not having leaps to sort of rarely used tones in a particular melody. So this is something that I don't think any of us would have necessarily predicted ahead of time, but it seems to reliably occur across all of these different cultures. They also seem to have more triple meter. That one's a little bit harder to nail down. I'm not sure we want to take that one to the bank because triple meter in these lullabies is quite a bit more ambiguous than our other features, but I'll leave it up there for now. And then classifying the difference between lullabies and love songs. Some of you may be familiar with Sandra Trieb's wonderful paper from the early 90s, where she actually used love songs as control songs when asking humans to identify the differences between songs. So these songs are actually quite similar to one another. And you can see that the model performs the worst from these categories at distinguishing these. But nonetheless, there are some features that reliably distinguish these song types from one another. Again, fewer rhythmic accents, and importantly, a narrower pitch range. So love songs tend to use a much wider set of pitches, which is sort of consistent with the idea that love songs have a lot more information in them. They're including a lot more sort of ornamentation and maybe more florid musical devices. Now we can make the same map for all of our comparisons. I won't talk through all of these, but if you're interested in the differences that we find reliably around the world, there's a big table of them in our science paper. And I've highlighted some of the biggest effects here just for you to take a look at. Okay, so we know from that first paper, adults are making these reliable high-level inferences about the music that they hear. And what these findings from our machine learning work tell us is that these inferences are rational. They're based on features of music that reliably do occur in the cultures that produce these songs. They're based on universal features of musical forms and musical behaviors. Now, we were interested in a sort of corollary question, which is the fact that our listeners on the internet and all of us on this call have quite a bit of shared musical experience. Now, it could be that our web-based listeners have a big sort of many, many years of experience listening to songs that are used in lullaby or dance or healing contexts. And based on that experience, we apply our experience to the music that's recorded in these many different small-scale societies. And our experience is similar enough to those different cultures that it's enough to give us the effects of the size that we're finding here. Now, if that were the case, and it had nothing to do with how our minds were designed, that would already be kind of cool. It would be interesting if cultural evolution had shaped our shared musical experiences as web-based, industrialized listeners to a point where the musical intuitions that we have are very similar to those that are found in very disparate small-scale societies. But we wondered, how much of is our experience playing a role in that? However it turns out, it'll be interesting, but we'd like to measure it. So to do that, we studied a population of children. And of course, children, as they grow up, get a ton of musical experience across many, many different contexts through their childhood. And in this project, which is led by my student in New Zealand, Liam Crowley-Detiri, he used our web-based data collection techniques to get a large group of children to do a similar experiment. So this is our kids music quiz. And again, if you have a child, we'd love to have your child participate. So go to themusiclab.org and check it out. The game is very, very simple. We've had about 18,000 children participate so far. And it's an animated, simplified version of our world music quiz. This little character is Susie the Star. She has an adorable Kiwi accent. And she walks our children through this game, explaining that some songs can be used for different things. And we'd like you to guess what these songs are being used for. So what do we find? In this plot, I'm not going to show all 18,000 children. I'm filtering very conservatively to children who only completed the game and also balancing across age groups from age 3 to 12. We have a bias in our results towards older kids, 14, 15, and we wanted to focus on early childhood. So I'm only plotting 1,700 children for now, but the paper, whenever it gets written, we're a little bit behind on that. Whenever it gets written, we'll have more children than this in it. So the first question is just how similar are the children to the adults? So in each panel of this plot, I'll show the proportion of responses in the correct category. So lullabies, dance songs, or healing songs, predicting child responses from adult responses. So if they agree with one another, we should see straight lines. And if they disagree with one another, we should see clouds of points or some other pattern. Here's what we find. Children and adults have very, very similar intuitions to one another about whether a song is being used as a lullaby, a dance song, or a healing song. One thing I forgot to mention is that we left our love songs out of this, mainly because we thought it would be kind of confusing to, say, a 3 or 4-year-old what constitutes a love song, whereas lullabies, dance songs, and healing songs are a little bit easier to explain in that they're associated with a physical outcome, like putting a baby to sleep. So this is our first finding here is that the children and the adults have very similar intuitions to one another. The intuitions are also accurate, so we see quite high D prime scores adjusting for base rates of responses in the children. So these D primes correspond to what the children's responses are. And then we wanted to ask, okay, they're similar to one another, but how does this change over the course of childhood? Well, we have a nice large population of children, and we took from our subset of kids aged 3 to 12, where we've got, I think, between 150 and 250 children at each age group. And we can just ask, how does this change over the course as they grow up? Because as they grow up, they're getting more and more experience. You might expect to see their performance increase to about the level of adults, but starting from at chance or below. This is what I thought was going to happen. This may be what you also think is going to happen, and it's not at all what we find. This is the result. It's extremely, extremely flat. That is a very small R-squared value. And I'm not totally sure what to do with this yet. In fact, I'd be interested to hear in the Q&A whether you buy that this result is as flat as it is. This is some of our newest work from as I mentioned, Liam Crowley-Detiri. And I'm a little shocked because 3-year-olds are very different than 12-year-olds in a number of ways. We have a 3-year-old here. He's great, but not really good at tasks. And it's a bit surprising that the 12-year-olds are not appreciably better than the 3-year-olds in this task. So what I take from this for now, and this is, again, a sort of a new result, so I'm not sure I want to take it to the bank yet, but what I take from this is that there doesn't seem to be a strong requirement for substantial experience in making the sorts of high-level inferences that we have here. Now, I should have put a little asterisk on that finding because it's new and we're not really sure what to take from it yet, but here's a possible interpretation. And one reason I'm sort of comfortable making that kind of interpretation comes from our work with infants. So we had a paper come out a couple of weeks ago, run by Connie Bainbridge and Mila Bertolo, where we studied responses to these songs in very young infants. Now, very young infants, it would be nice to ask if they have a lullaby concept, for instance, or a dance concept. That's a bit of a harder task than measuring something a little bit lower level, such as their physiological responses to music. So that's the point at which we started. In particular because infants have a very canonical response to lullabies. They tend to relax when they listen to lullabies, especially familiar ones that they hear a lot from their parents and from other people who they know in the context of soothing environments. Our new baby knows very well, after not that much experience, that, you know, if one of us starts singing to them, they're in a safe place. It's all good. They're going to calm down. They're being looked after. So we wanted to ask, is it the case that the musical features in these very foreign, unfamiliar songs are sufficient to produce similar results in infants who have not been acculturated into these different cultures whose music we've recorded? The way we tested this is with an animated study. These characters might look a little bit spooky or weird to you, but to infants who've been in developmental studies before, these are kind of fun, nice-looking characters. They enjoy looking at them. And what we do is we introduce them to these characters and associate one category of song with one character, and some other set of songs with the other category. The experiment's super simple. They hear one character sing a song, let's say a lullaby for the blue guy. They hear another song from the other category, let's say a non-lullaby for the red guy, and then we give them the chance to look between these two characters in case they've developed a preference for one another. We do this 4 times, so each infant hears 8 songs, and across those 8 songs, they're hearing lots and lots of different cultures' music. So the songs come from the NHS discography. They're chosen with a very simple selection algorithm that aims to reduce some of the confounds from our adult work. For instance, we don't present any songs that have accompanying instruments. We match the perceived gender of the singer so that there's not any kind of bias towards voices that sound female to the infants. There's quite a bit of work in developmental psychology showing that infants prefer female voices or female sounding voices. Another caveat there is that perceived gender is not at all the same as actual gender, but we'll leave that for another time. And the songs come from 15 different cultures on 6 continents. So they're getting a pretty diverse sample of music, of course, in languages that they've never heard before, and from cultures that they're totally unfamiliar with. These are all infants from the Boston area. I'll just play you a video of it. This is what it looks like. That's one song. And the main outcome measure that we're interested in here is looking at relaxation, which we measure using heart rate as a proxy because from a lot of studies of music listening, we know that heart rate drops when people are calm, relaxed while they're listening to music. So what do we find? On this plot, I'm going to show the progression of heart rate on average over the course of a trial, averaging across all the trials that an infant heard. And the first result here is that heart rate drops. This is unsurprising to anyone who's run a psychophysiology experiment. When people are sitting comfortably listening to something nice, their heart rates slow down. But what we find is that when the songs that they're listening to are lullabies, the drop is appreciably larger than non-lullabies. So much so that on average, heart rate during lullabies is below 0 relative to the previous trial, and not below 0 relative to the previous trial when they're listening to non-lullabies. So that translates to a relaxation effect when it comes to heart rate for lullabies, but not for non-lullabies. In the paper, there's a bunch of other psychophys measures. I don't have enough time to look at them right now, but we can maybe talk about them in the Q&A. One thing I want to point out, though, is that because we have a nice large group of infants, this is 144 infants across a number of different ages, we can use a similar style analysis to our web-based study of children and ask how does this effect change over the course of their very early experience. So anyone with an infant knows that a 2-month-old is very different than a 12-month-old. And there's quite a bit of musical experience that happens in that first year of life. So you might expect to see a change in effects here, where maybe the older infants who've heard more lullabies are more likely to relax in response to these lullabies than the younger lullabies. And that's not at all what we find. The negative effect of listening to these foreign lullabies on heart rate, the drop in heart rate, is consistent across these age groups. And this line is not different than, the slope of this line is not different than 0. We don't see any appreciable change. So from that, I take the finding that these universal features that are producing these universal features that are producing the high-level inferences that adults are making and that our children are making as well, there are signatures of effects of those features in young infants. Now, I wouldn't go so far as to say that these infants understand what a lullaby is. In fact, my bet is that they don't. But I think this gives us a little bit of license to support that third bullet point there, where the children are not requiring much substantial experience to make these inferences. That's sort of rational, given that even their really, really younger siblings would have a similar response to lullabies from many, many different cultures, even though those cultures have nothing to do with one another. Okay. So I'll just wrap up the talk here by circling back to the question I started out with. Why should we care about studying music in cross-cultural perspective? Well, I think if we're going to really understand how the psychology of music actually works, we need to carve this into its constituent parts. We need to figure out what are the actual inferences that music listeners are making when they hear music. And that's going to mean, by its very nature of the question, studying people across different cultures. Because we're not interested in the psychology of upper middle class white people, or at least I'm not. I'm interested in the psychology of human listeners. And that means paying quite a bit of attention to music across different cultures. So I'm interested to hear what you think, and we can maybe have a bit of discussion. But thanks to the funders who paid for this research, and to all of my students who've actually made it happen, who are collectively referred to by the logo for our lab. And if you're interested in participating in our research, check it out. Go to our site, and you can play our games and become a data point in one of our studies. So thanks, everyone.
Okay, thank you very much. I'll clap on behalf of the audience. So that's me clapping, and you can hear lots of other people clapping at the same time. So we have some questions in the Q&A. I just wanted to take advantage of the fact that I have the microphone to ask my question first, encouraging others to keep adding to the Q&A. So did you have in advance specific hypotheses about what universal features to look for? That's one of the things I didn't gather. The whole idea of universality, universal features, is it like a hypothesis, or we just throw in all our methods at the big data to find it, and we find whatever we find?
Yeah, so that's really interesting. I think it depends who you ask. For some category differences, I think there's pretty good theoretical motivation for the sorts of acoustic features you might expect to find in one culture or another. Looks like we've got someone sharing the screen by accident here. There we go. So it is the case that you might have some hypotheses. In fact, there's lots of work, in particular from Laurel's lab, from Sandra Triev's lab, and many other places, proposing particular types of features. Personally, because my lab is particularly interested in infant-directed speech and infant-directed song, there's a number of acoustical features in infant-directed speech that you might expect to be exaggerated in infant-directed song across cultures, and you would have a strong theoretical prediction for those. We have a paper in revision now that's looking in particular at that comparison. But what I find kind of compelling about the approach that we take in the science paper is that the model doesn't care what our hypotheses are. The model is purely a bottom-up, data-driven approach where it just asks, given a lot of information about the songs that are used across these cultures, do we get results independently of our own biases, our own particular pet theories about what songs are being used for? Does that validate any of these theories? And when it does, I think we can take those results to the bank. I think we can really buy that rhythmic accents are not are not, brought out in lullabies around the world. Especially in cases where the acoustics of those features are consistent with the physiological properties of the listeners. Rhythmic accents wake infants up. So it's not surprising that you would find fewer of them in lullabies. So I'm not sure if I actually answered your question, but I guess if I could do it in a word, the answer would be sort of yes and no, or both. We care both about hypothesis-driven results here and bottom-up data-driven approaches.
Could I step in, or
somebody wants to continue directly?
Excuse
do
me?
you have a comment to make on this question, or you have a new question?
I couldn't write a question, but
Okay.
I have a question. Can I ask?
Of course, please go ahead.
In as much as two people don't hear the same way, how do you account for that variability, in addition to factors such as volume and tempo that characterize the quality of any piece of music?
Yes, that's a great question. So we have we have the intuition that different people have very different perceptions of the music that they hear, and these results are actually quite consistent with that story and with that view. We don't find, for instance, that 95% of our listeners agree about what each song is. We don't find that at all, and in fact, I suspect that there's measurement invariance. There's measurement variance in the accuracy with which some of these songs were originally categorized. Some of the anthropologists who collected these recordings and said this is really a lullaby were probably wrong, just by virtue of the fact that they're collecting data in a difficult environment. What's important to take away from these findings, I think, is not that there's a one-to-one correspondence with the acoustic world of music production and the high-level representations that music listeners bring to that music. What you should take from it is that there are clear biases in listener intuitions that are consistent with one another around the world, and that are also consistent with people who have less experience than those listeners, specifically the children that we've studied, and even the infants, if we take their psychophysiological effects as sort of proxies for categorization results. So I would totally agree that different listeners are going to have totally different views of the music that they hear. But the finding here is that there are universal biases towards what people think is going on in music. This is a psychological effect, not a cultural effect.
And volume and tempo.
Yeah, so those two features are two of many that characterize these differences. And if you check out, there's a table in our science paper, table 2, that goes into quite a few of those features in detail. There's also a very, very long supplement to that paper for anyone who's interested in some light reading. Like, print it out, put it in your bathroom, hang out with it. There are many, many more features discussed in the supplement. Yeah.
Yeah, this was a very long supplement. We struggled with that.
Us too.
All right, let me go to the next question then. Elizabeth Phillips, is there a reason for using a 6-point scale instead of a 7-point scale? Did you want to avoid neutral responses for some reason?
No, there's not really any reason for it. We've actually run similar experiments with 4-point scales, 9-point scales, 11-point scales, scales that have a midpoint and scales that don't. The result seems impervious to any method that we try to throw at it to get this result to go away. The paper that my students and I are working on now using these methods is studying the same effects in different populations. So in a few small-scale societies, in different languages with native speakers of different languages who don't speak English. And there we used a 4-point scale and repeat it quite clearly. And part of the motivation, as I mentioned, for the conceptual replication that we ran online that had a categorical distinction between the song categories rather than a scale was to deal with that problem. Was to give a totally different method for getting at the same effect, and it replicated quite clearly.
Next question from Elise Piazza. How do you account for the impact of gender or potentially other vocal features on the representation in the song sample and people's ratings? For example, are lullabies more likely to be sung by women, which could drive people's categorization?
Definitely. Hi, Elise. So that is a big difference between the lullaby category and the other categories. Purely through sampling, we get many more female singers of lullabies, and this is true in many small-scale societies where women tend to take the lion's share of childcare. There are a couple of ways that we deal with that problem. First, when we study, for example, musical features that do not indicate anything about gender. So the machine learning results that I mentioned, I didn't go into details about what data are being fed into that model. But the main set of results that's reported in the paper and that I had a few slides on only uses features that have nothing to do with gender. They're things like, pitch density and range and that kind of thing, where within the singer, there's not any difference between male or female singers. So that's one way that we deal with it. Another way that we deal with it is, for instance, in the infant paper, all of the pairs of songs are gender matched. So we actually have 16 songs in the study, but each infant only hears 8, and they only hear male singers or female singers. So the within subjects result is independent of gender. But it's definitely a problem in, for instance, the current bio paper where it's just listeners rating songs. And their gender is confounded with the musical features.
Okay, thank you. Next one, anonymous. It's more of a conjecture hypothesis. Is the minor key more used in lullaby than in love song because it is a key inducing us or suggesting a low emotional excitement or charge? Please comment.
I don't know. I would hesitate to speculate, especially in a room full of people who know more about this than I do. So I would defer to others, maybe on the chat, about why there might be an effect there. And also I would just point out, like the triple meter result that I sort of caveated when I presented it, ascribing a minor key tendency or a triple meter tendency is a much higher much more difficult inference to make than more objective features of the acoustic content of these songs. Like tempo is a little bit easier to identify than something like minor key. So I'm not sure I would go so far as to make an inference about it if I'm not totally sure that it's a reliable cross-cultural effect.
Next we have something more technical, I guess, by March Miguel. Could the effect of the feature by Lasso be tested by modifying the transcribed songs?
So the Lasso results that I presented actually use very few of the transcribed features. In the paper itself, we run the Lasso on each of the different data types, essentially to ask that question. We wanted to be sure that, by virtue of using staff notation to extract information from songs, we weren't biasing the result in one direction or another. So some of our analyses use the transcriptions and others don't. There are 4 different data sets that we use, which I mentioned in the talk. There's music information retrieval, naive listeners, expert listeners, and transcriptions. And the results replicate across the 4 different song types. What's sort of interesting to me methodologically is that the type of data that is being fed into the Lasso affects the accuracy of the Lasso. So it might be bad news to the engineers among us, but the music information retrieval features are the worst performing. The transcription features are the best performing. The expert listeners and the naive listeners are somewhere in the middle.
Okay, thank you. Next, by Daria Digileva. I'm sorry if I'm not saying it right. Does the language of the song influence on the perception of it? For example, if the language is tonal.
This is a very interesting question. So the short answer is a little bit. In the data that we've published so far, we don't do very detailed analysis of language because there are so many languages that are unfamiliar to all of our listeners. So many of the cultures where these songs are coming from are small-scale societies. They speak endangered languages or languages that are now extinct but weren't when the song was recorded. So that it's not an issue that can account for the pattern of results that we have. But it's a very interesting topic for what the psychology of music listening is. And there's 2 bits of data that I'll mention about that, both of which are unpublished and both of which don't quote me on because I'm not sure if they're going to hold up. The first is that when we do an analysis where we have a much broader set of listeners who are native speakers of languages that are related to the languages that are used in these songs, so not the same language as the song, but languages that are from the same sort of chunk of the language phylogeny, for instance, we do see a very small effect of language familiarity, such that if you're listening to a song that's in a more closely related language to your language than a song that's farther, more distantly related, you're slightly better at identifying it. But the effects are very, very small, such that if you regress out those effects, you get practically the same result. So that's finding number one. Finding number two comes from a totally unrelated study, which is from my student Jing Liu, who is in Beijing and is doing some awesome work on tonal languages and music perception ability. So if you've gone to our website, you've probably played our most popular game, which is our musical IQ test, which we've controversially titled as an IQ test just to get more people to do it. It has nothing to do with IQ, of course. It's a music perception test in a few different domains. What Jing finds in her research is that people who speak a tonal language natively have a very different profile of results on these tests than people who don't speak a tonal language. And this has been a topic in music perception research for quite a long time, but it's a topic that doesn't have a very clear set of results, mainly for a very boring reason, which is that it's hard to run these studies with a lot of participants. It's hard to get a ton of native tonal language speakers and non-tonal language speakers and pitch accented language speakers in your study. But when you've run a study that has, 2 million participants in it, all you have to do is subset and do some careful sampling from your large sample. And that's what Jing's done. And she finds that there are, in fact, effects of listening to, of having spoken a tonal language on your music perception ability. But those effects are at the perceptual level. They don't seem to have anything to do with really high-level representations of the sort that we're talking about in this work. So it's a very cool topic, though, and we're kind of excited about it because this is new results that we just heard about them last week in my lab meeting, actually.
Okay, well, it's past the time, and unfortunately, we cannot get to all there are a few more questions left. There's one long comment by Peter Cariani. I love Peter Cariani's work. He's very original. He's a very original thinker. It basically has to do with the neuroscience of it. Then if you really want to see your questions, just copy paste them in the chat and you can keep discussing there. So I would just like to thank again our speaker. I'm clapping on behalf of everybody else. And
thanks everyone.
Call the session for now.